moving on to question 3 here, we have a question on differentiation. So we have a quotient, so we're going to use the quotient rule. So it's given in your formula books, you don't need to worry about memorising it. So let's have a look at tackling this. So remember, for the quotient rule and the product rule, the nice way to do it is always write down everything that you're doing. So let's write down what u is, and let's write down v. So u will be my numerator, so that's 5x squared. 5x squared plus 10x. So the differential of that, u prime, well, that's going to be 10x plus 10. 10x plus 10. So I'm hoping I've got enough room here to do v. So v will just be my denominator. So x plus 1 all squared. So x plus 1 squared. And then the differential of that, so v prime, well, this would be chain rule. So we bring the 2 down in front, so that's going to be 2 times this, and we take 1 off the denominator, the power. So that 2 will become a 1, and we times by whatever the differential of the bracket is. But obviously the differential of this bracket is just going to be 1, so it's going to be 2 times 1 times the bracket and take 1 off the power. So it's 2 lots of x plus 1. So that's the first step of this question, getting your u, v, and u prime and v prime. So let's have a go at using the quotient rule now. So it's given in your formula book, but after enough of these questions, you'll have it memorised. Unfortunately, for some of you, if you don't plan to do A-level maths at university or anything like that, you just have it memorised. But what dy by dx is going to be now? So dy by dx. So that's going to be u prime times by v. So hopefully we'll have enough room. That's going to be x plus 1 all squared times 10x plus 10. So remember, you have to get the order correct with this, guys. And whether you do u prime times v first or u times v prime, it's always u prime times v for quotient rule. Doesn't matter with product rule because it's just multiplication, but quotient rule does matter because we're going to subtract off here. So then we do v prime times u. So that's going to be minus 2 lots of x plus 1 times 5x squared plus 10x plus 10x. And this is all divided by v squared. So v is x plus 1 squared. So if we square this, that's going to be x plus 1 all squared again. So that's going to be x plus 1 to the power of 4. That's my denominator. So what we've got to do now is we've got to simplify. We should end up with a divided by x plus 1 to the n, where a and n are just constants to be found. So this should simplify quite nicely. The first step to look at is look if we have any factors that we can cancel. So we have an x plus 1 squared here, we have an x plus 1, and we have an x plus 1 divided by, to the power of 4. So we can cancel at least one x plus 1. We can cancel that one there and one of the powers there. So that's going to come to a power of 3. So that's going to become 3. And now all we need to do is expand all the brackets, and hopefully this should simplify very nicely. So using FOIL here, x times 10x will be 10x squared. That's 10x squared. X times 10 will be 10x. And then 1 times 10x will be 10x again. 1 times 10 will be plus 10. Now we're going to subtract off here. So minus 2 lots of 5x squared. That's going to be minus 10x squared. And then minus 2 times 10x. That's going to be minus 20x. And then remember, we've still got this denominator here. We've got x plus 1 to the power of 3. X plus 1 to the power of 3. Like so. So now, let's have a look to see if anything cancels. Well, we've got a positive 10x squared, we've got minus. They cancel. There's no x squared, so they just cancel. 10x plus 10x is 20x, minus 20x. So they cancel with the minus 20x. And all we actually get left with is 10. So this is equal to 10 divided by x plus 1 all cubed. And there we have it. Your A is 10 and N is 3. So A is equal to 10 and N is 3. And there we have it. That's the 4 marks for that part. So that's the highest part of this question done. And then part B is just a 1 marker. It says, hence, deduce the range of values for x for which dy by dx is less than 0. So, how do we do a question like this? Well, we need to know where d by dx is less than 0. Less than 0. So, where is this less than 0? Well, dy by dx is this that we've just worked out. So, where is 10 divided by x plus 1 all cubed less than 0? Where is this less than 0? So remember, the nice thing about this question is you have a 0 on this side. So I can times both sides by x plus 1 all cubed. We're going to times by the denominator here. Well, if I times this side by x plus 1 all cubed, nothing's going to happen. Anything times 0 is just 0. But we're going to get 10 lots of this on the numerator. So what we're actually going to end up with now is 10 lots of x plus 1 all cubed is less than 0. Now, we can make this even easier. We can divide it through by the 10 on both sides. 0 divided by 10 is just still 0, and, well, 10 divided by 10 is just going to be 1. So that's going to cancel here. So what we have now is where x plus 1 cubed is less than 0. So x plus 1 cubed less than 0. So think back to your inequalities and quadratic and just cubic inequalities. What you're looking for is where this graph is less than 0. So basically this question is just assessing if you know how cubics work. So if I draw a sketch, it's going to look something like this. So what this is this is x plus 1 times x plus 1 times x plus 1. So where's my root going to be for this? Well, it's going to be a repeated root at x equals minus 1. So if this is minus 1 here, well, it's going to be a repeated root, so it's going to look something like that, right? Again, I'm not an artist, so you know it's not going to look perfect. And this is going to cut through at 1 as well. So I'll say that's my 1 point on the y-axis. So y and x. And again, this isn't going to look perfect, but it's just a general idea. That's supposed to be a repeated root going up through 1. So that's a really poor sketch, but just to give you an idea. So where's this graph less than 0? So this graph is less than 0 past minus 1. So therefore, x must be less than minus 1. And that's all you need for the last part, part B. It's just understanding of cubics and, you know, intersections. So that's question 3 done.